Welcome to the Engineering at Deakin course information session. I'm Professor Ben Horan and I'm the Head of School for the School of Engineering. To start our presentation, I'd like to make an acknowledgement of country. As we gather here for this meeting, physically dispersed and virtually constructed, let us take a moment to reflect on the meaning of place, and in doing so recognise the various traditional lands on which we do our business today. Deakin would like to acknowledge traditional custodians of the land on which the university campuses are based. The Wadawurrung people of the Kulin Nations, on whose country our Geelong campuses are located, the Wurundjeri people of the Kulin Nations, on whose country our Burwood campus is located, and the Peak Wurrung people of the Maar Nation, on whose country our Warrnambool campus is located. I myself am located on Wurundjeri country, and on behalf of us all, I pay our respects to all of our Aboriginal and Torres Strait Islander traditional custodians, elders and ancestors of the lands from which they may be joining our gathering today. I express our gratitude for their care of country, which continues to sustain us as it has done for millennia. Education has a long and rich heritage in this continent, which we aim to honour and reflect in the ways we teach and learn. Now let's overview the presentation for today. What is engineering, and why should you study engineering at Deakin University? What are the undergraduate engineering courses we offer? What are the facilities you'll study in? What is our take on professional engineering practice? What about final year research projects? Industry partnerships? What are Manufutures in the IFM? How about elective study or elective units? Scholarships, careers as an engineer, and entry requirements. If you are joining us as an international student, please join our international study experts in the sessions listed below, listed on the page there, to learn more about joining the Deakin community. These information sessions are Apply to Deakin as an international student, Fees and scholarships for international students, and International life at Deakin. You can also join us for a live Q&A this afternoon to ask your questions and hear from current students. You can also ask questions at any time using the web chat by clicking the yellow speech bubble icon on the bottom right-hand corner of your screen. Engineering. Design and innovation are at the heart of engineering and studying engineering at Deakin University. You'll learn from courses that go beyond theory, but also involve state-of-the-art facilities and practical programs which will help you learn to create innovative engineering solutions to real-world problems. It is one of the big differentiators for our undergraduate engineering courses at Deakin. Our courses have project-oriented design-based learning. So you'll find about half of your course will be structured in a traditional way where you have a unit of study, you have classes, seminars, practicals, things like that, exams, and so on. But then in the other half of the course, you will undertake units where you're asked to analyse a problem and design a solution to that problem, meaning that aside from getting the opportunity to learn and implement those engineering principles, you'll gain from the soft skills gained through that experience. What do we mean by soft skills? Working in teams, communication, time management. A lot of the skills that are really relevant to your employability as a graduate engineer when you finish the course. Our engineering courses at Deakin mean that you will graduate with international recognition. Our undergraduate courses are professionally accredited by Engineers Australia, that is signed up to the Washington Accord, meaning other Washington Accord relevant countries will recognise your engineering qualification. Our undergraduate courses require you to gain 12 weeks of industry work experience, meaning that you will graduate more job ready than what you would be if you didn't have that industry experience. It is possible to study our degrees partly or fully online via the cloud. So there is a flexible online study option available. We also have a trimester calendar. So in addition to the regular 2 semesters or trimesters, we have a trimester 3, which in some instances provides the opportunity to take a unit in trimester 3 as opposed to those two more traditional trimesters, the first one at the start and the second one in the second half of the year. And as mentioned before, we pride ourselves on a hands-on approach we take as part of our course, that we have project-oriented design-based learning, or we refer to as PODBL, meaning that students get to apply their learnings as well as learn those really important soft skills that go hand in hand with the harder technical skills that are essential to being an engineer. I mentioned we do have a flexible online cloud learning option. We are at Deakin University and in the School of Engineering a leader in online learning. Delivering over digital platforms and remote platforms is in our DNA, and we have over 40 years of distance and online learning excellence. Now, some of you will be thinking, well, the internet wasn't around 40 years ago, and you're right. Back then, it was via correspondence, by sending out material, receiving material. Fortunately, the internet and some of the great platforms we employ at Deakin University, like Cloud Deakin, mean that you can do this in a much more efficient manner. And you may be wondering, what about being an online or a cloud student? Do I graduate with the same degree? Absolutely. At Deakin University, we have a wide range of online students studying via the cloud, and many who have studied a Bachelor of Engineering degree and graduated successfully. It's a little bit of a history of online learning at Deakin University. So in 1976, there was a flexible study with off-campus and mixed mode courses. And then, computer-based tutorials, digital education came in 91. Then 2010, which isn't that long ago, video conferencing tool for live off-campus classes. And then more recently, 2021, for instance, we have online chat platforms, Facebook messaging, Zoom, phone, email, Microsoft Teams, study support, online library, IT, and more. And the suite of tools that support you should you study online are very comprehensive. So it's an option to consider if studying on campus isn't going to work for you. So we spoke before about project-oriented design-based learning, but let's go over it a little bit more. You learn engineering by solving real-world industry problems. The whole course isn't that way, but half of it is. You undertake hands-on design, research, testing, and problem solving. In these units, in those project activities, you typically have smaller class sizes to maximise the interaction between students and staff. And those professional practice and soft skills are going to be much stronger because you've undertaken more of that activity, as opposed to studying for an exam. It's a very independent activity and not going to expose you to some of the things that you'll need as a graduating engineer. And then in that type of environment, the assessment can be much more authentic, much better reflecting the real world, because you are solving simulated, albeit smaller, real world problems. So the assessment can be a lot more realistic. Okay, so let's now have a look at civil engineering. So civil engineering is one of the 5 undergraduate engineering specializations we offer. And civil engineering is around designing, building, and maintaining built infrastructure systems to ensure sustainability, to improve livability, and ultimately to advance civilization. You'll notice that for all of our engineering degrees, the type of work that the graduate of a particular degree ends up in are quite diverse, and civil engineering is no exception. Civil engineers work in construction companies, councils, road and transport authorities, water authorities, government bodies, consulting firms, and mining companies, just to name a few. And sometimes prospective students, those thinking of studying a particular engineering discipline, come and say, look, what sort of job would I get? And I think the best way is to load up a job platform like seek.com.au and type in civil engineering, just have a look, or civil engineering graduate, and have a look at the type of companies that are looking for civil engineers or civil engineering graduates, to get a real world idea of some of the organisations that are employing civil engineers. I think that's a much more robust way for you to get that sort of information, rather than hearing it from us. Environmental engineering is the second engineering degree we're going to talk about here. And environmental engineers essentially protect the environment. People entering an environmental engineering degree want to design and work on groundbreaking engineering solutions for a sustainable future. They assess the impact of past, present, and future projects, as well as developing solutions to minimise the effect of our way of living, what we need to do in our own lives, what does industry need to do to keep the world moving, but how do we do it in such a way that we minimise the impact and the negative effect on the environment? Environmental engineers address global and then as well local environmental issues, things like climate change, sustainability, recycling, public health, air and water, as well as things like pollution and contamination. Again, a very wide set of opportunities for those that graduate with an environmental engineering degree. Now, electrical and electronics engineering. In a nutshell, electrical engineers are the people who make sure we have power and electricity, as well as they work on control systems that control some of the things that we do. They belong to a workforce that supports vital infrastructure that generates, transports, and distributes electricity and power, which is something that we know impacts everybody's lives. It shapes the way we live, and without electricity and power, it would be nearly impossible to live like we do today. Just look around the things that you use every day: lights, computers, televisions, household electrical appliances, even your cars. Your cars do have a significant electrical and electronic component. And then some of you may even own a Tesla. A Tesla is fully electrical. It's not mechanically driven. It's driven by electric motors controlled by electronic systems. Electrical and electronic engineers are highly depended on by society because they're involved in designing the equipment that provides power, how we communicate, and how we control things using electronic systems. As an electrical engineer, you'll study and apply the physics of and understand the physics of. You'll study and apply the principles of physics and mathematics to electricity, electromagnetism, and electronics to both small and large scale processes. For those looking at what's happening in terms of trends in Australia and the way we use energy, we can see Australia is accelerating its transition to renewable energy, things like solar, hydro, wind, and moving away from some of the more traditional technologies like coal power power plants. So, Australia's energy sector is massive. A lot of work is going to happen. So I think it's a fair bet to say, although, we know that all of our engineers go in different directions, a lot of our graduates that study electrical and electronics engineering are going to end up in the power sector and are going to play a role in helping Australia with that transition to renewable energy. Mechatronics engineering is one way to think of it. It's the mix of electrical, mechanical, and sometimes even robotics engineering into a single degree. And you can land a career shaping innovative robotic systems or innovative, electromechanical systems that have an electrical and possibly an electronic component with mechanical components. So this degree is newer than some of the more traditional degrees, but it's been around for quite a while, and we're seeing an increasing demand from industry for people that can work at the intersection of mechanical and electrical engineering. We use the automobile, your car, as an example before. Let's go back to that example to think about what a mechatronics engineer does. Well, in most of your cars, you're going to have an internal combustion engine. You have fuel, you have combustion, you have a mechanical engine which provides the propulsion for your vehicle. Now, that in itself is something that would have been designed by mechanical engineers, but you can't go very far from that mechanical engine before you're going to encounter electrical engineering and electronics engineering. Most of the engines in your cars these days are going to have ECUs, electronic control units. These are, as the name would imply, electronic units which control your car. So unless you have a vehicle which is pre-fuel injectors, pre-ECUs, it's going to largely rely on electrical and electronic engineering to make it work. That's just one example, but you can see that interface between mechanical and electrical is very strong, and hence why there is such a demand for mechatronics engineers in society these days. So mechatronics engineers can create diverse products, such as substitutes for human sensors and organs, computer-controlled machine tools. It's probably one of the most diverse of our engineering degrees we offer at Deakin. The nature of the jobs that students can end up in are wide. Mechatronics, as I've suggested, is a rapidly developing field. And as the world becomes more technologically advanced, it's going to be of increasing importance. They are the one way to think of a mechanical engineer is the brains behind systems, machines, machinery, devices, big and small. And before we were talking about the car engine, but I mean that's just one of thousands and thousands of different examples of where a mechanical engineer may have been involved at some stage in designing that particular mechanism or technology or engine. The graduates of mechanical engineering go into a wide range of fields, into product development, to mining, to biomedical, rail and road, aerospace, textiles, automotive, research and development, field and test engineering, advanced manufacturing, sports technologies. And mechanical engineers contribute to designing, developing, analysing and building the manufacture of physical stuff. Physical things. If you look around for something physical around you that's been manufactured, very high chance that a mechanical engineer has played some part. Now, to where you'll study. So we've spoken about studying on campus and online via the cloud. If you're studying on campus, most of your learning is going to happen in our engineering building on the Geelong Waurn Ponds campus, where we have state-of-the-art simulation and visualization systems, purpose-built interactive laboratories and workshop spaces. And in fact, the building was built around the learning experience, and that'll become very obvious once you have a chance to look around. Now, if you're studying via the cloud, well, that would mean a lot of your study is going to happen online via the Cloud Deakin platform. But of course, being engineering, there are things that you need to come on campus to do. So we have intensive weeks, which you're informed of well in advance, where you come onto campus to do essential practicals and other activities which are really essential to your study. Our students do have access to some of the best future-focused engineering and design facilities. And just to name a couple of our very high-end, and in fact, world-class labs, we have our virtual reality or our VR lab, where students work on things like their final year project, learning how to design virtual reality and augmented reality experiences, and also using this type of technology as a tool for visualizing what happens in when you create a design using a computer program, for instance. We also have a high voltage or HV lab where students can look at what it's like to generate really high voltages and their impact on different electronic or other components. We also have a very impressive and what we think is one of the largest 3D printing facilities in the Southern. So I've talked about some of the key labs in the general facility, but we have a mechatronics lab that has things like PCB mills, soldering stations, robotics platforms, automation trainers. In a civil engineering lab, we have a wide range of, our civil engineering and environmental engineering labs, we have a wide range of different test equipment which students can conduct experiments, see how things work, monitor things with sensors, run simulations and things like that. And we do have laboratories aligning with all of the different units across the 5 engineering degrees. We spoke a little bit about our high voltage lab, and here's a picture of it. And if you do get a chance to visit the campus, there's a very good chance you'll see this. And if you do get the chance, definitely do, because what we have is an entire laboratory that's dedicated to the ability to safely test really high voltages, but also high frequency signals. And the way it works is it uses a Faraday cage, so a large electrical conductor surrounding the whole room, meaning that if any voltages that are present, they are then grounded, they're sent to ground. That's something you'd learn if you were studying electrical and electronics engineering, and meaning that it's safe to observe what's happening in the facility. So it's a really fantastic opportunity to see, what electrical engineering is in action. a virtual reality lab as well, like the high voltage lab. You get the opportunity to see it. It's fantastic. It's going to show you some of these emerging technologies that are starting to be used in the sector and what they mean for engineering. Now, a facility we haven't spoken about yet, but is really important, is our microgrid. Deakin University's microgrid is a 7-megawatt solar energy farm on the Geelong Warn Ponds campus. So this is an aerial drone picture that you can see. And this powers half of the campus. So we spoke about Australia's transition to renewable energy and how important that is, and how some of our engineers, including those obviously studying electrical and electronics engineering, are going to play a large part in that happening in the future. But as a university, we like to be at the forefront. We like to be at the cutting edge. And we decided, well, we want to do this now. We want to be ahead of the curve and power as much of our campus as we can just from the sun. So we have an entire solar farm, and we don't use the term farm lightly. It is gigantic, which provides half of our campus's needs. And it also provides a teaching platform where students can get a better understanding about what these types of renewable energy devices can do, what their limitations are, and things like that. And this is also to help Deakin reach its aspiration to be carbon neutral by 2030. Professional engineering practice. So this applies to our various engineering degrees in a number of ways. One is through our project-oriented design-based learning. So by undertaking, designing solutions to simulate real-world problems, where you're going to get a better understanding of, what engineering practice is, which is largely projects and problem solving. But we mentioned earlier as well, you'll be required to undertake 12 weeks or 3 months in industry, meaning that you'll work in a real engineering team, you'll build industry experience, you'll start to create a professional network to complement your developing student network. You'll get a better idea of future career options, because you can see there were so many options for engineers, even in one discipline. It will help you start to shape where you'd like to go. And there also are overseas placement options as well, which I'd highly recommend to anybody, because they're going to be a fantastic experience and a really great contribution to your CV. So final year research projects. So in your final year of study, I spoke before about half of your degree being project-based. In the final year, you're almost an engineer. You've almost graduated. So it becomes an independent project where you spend half of your final year working on a project to look at some form of engineering innovation. Some people work on projects that have an industry sponsor or industry partner, some that have a research institute. We have a number of research institutes across the Deakin University Warn Ponds campus in engineering related areas. Or some might be with an academic supervisor who's identified a really solid project for you to undertake that's going to challenge you and really put into practice the engineering skills you've gained through your degree. We do also have a range of startup companies, some, believe it or not, which have spun off from engineering students who had an innovative idea and decided they wanted to go down the entrepreneurship path and to start up. And Manu Futures is an incubator accelerator where it provides subsidised grant training opportunities to give starting companies, emerging companies, a better chance to become competitive and nurture them a little bit, hence the term incubator. We do also have our Team Ascendcar, which is our aspiring entry for the 2023 Bridgestone World Solar Car Challenge. It's our first entry. We're going to see how it goes, but we're very, very keen and eager. And to date, hundreds of our students have undertaken their final year and other projects on that car, as well as doing internships and other things as well. The Warman competition, it's not a final year project. It's one you undertake if you're a second year mechanical or mechatronics student in a unit SEM 200. But there's another example of how that project type activity is across the different degrees. Now, we mentioned before the opportunities to go overseas. There are study abroad opportunities where you could, if you find the right institution and it maps to your course, spend time at an overseas institution, which I would, as I said before, highly recommend. And we do also have student societies, two being DES, Deakin Engineering Society, and LEAD, Ladies in Engineering at Deakin, which will be great for socialising, starting to build your network and have fun, because university, aside from being about study, is about enjoying yourself a little bit as well. The School of Engineering has a wide range of industry partners, and these are essential to what we do. We have an engineering advisory board, for instance, which advises us to make sure that our courses are focusing like they should. And we also have partnerships with a wide range of organisations that, for instance, provide work integrated learning opportunities. So that 12 weeks in industry, a lot of our partners are providing those places for our students. I spoke about Manu Futures before, but probably what I'll add here, and there's a picture, is that if you do get a chance to go for a tour of this on one of the Deakin tours, anytime, definitely do it. It's well worth it, I guarantee you. And we are going to launch a Manu Futures too. So you get the gist, it wasn't a one-off for us. We want to continue to push in this direction, continue to create opportunities. And Manu Futures 2 will have started to expand this year, and we're hoping will be complete by at some stage in 2023. Our Institute for Frontier Materials is an engineering-related research institute that largely just does research as well as trains PhD students, but they are a key partner to us. And a lot of our students have either undertaken projects with the Institute for Frontier Materials, typically our mechanical engineering students, or pursued PhD study opportunities post-graduation. We do have electives in our degree, and you can choose an elective from a wide range of specialisations depending on which discipline, which degree you're studying. So some examples: materials, performance and durability, additive manufacturing, product development, advanced manufacturing, or even an international study tour. And you can see a photo of Azelia here, one of our previous civil engineering students who's gone off into industry now, but took some photos there of her international experience during the international study tour. And then the smaller picture down there is really hard to make out, but there are other students that also went on a study tour as well. There are different scholarships that may be applicable to you. If you're interested, I would suggest going to this link and having a look. You'll have to search by the course, engineering related scholarships. One I will talk about briefly is the Ignited Scholarship, which has been created to ignite women's interest in areas including engineering and information technology. And this scholarship, they're all different, would provide a payment of $625 per credit point. And you do 32 credit points in a Bachelor of Engineering, plus an academic mentor would be provided. But they're all different, and I encourage you to check that out. Engineers are always going to be in need. If you future-proof your career, all of the engineering degrees we offer are in areas that without a doubt are going to continue to be in demand, and you don't have to look very far to realise that. Renewable energy, automation, resource management, new technologies and materials are some examples, just to name a few. In terms of career outcomes, we find that engineering is a degree that's in high demand by the industry. And 87% of those that are available for full-time employment are finding work full-time, right? And that's very, very high, as well as the median full-time salary of $75,000. We do have Deakin Talent, which helps students to explore career opportunities. So that's one of the services we do provide at Deakin. And then the entry requirements are also important to consider. And you can find these on our website. You can ask in the Q&A. But if you're leaving school, you'll need a Units 3 and 4 with a study score of at least 25 in English, EAL, or as a second language, or at least 20 in English other than EAL, as well as math methods of at least 20 for Units 3 and 4, or specialist mathematics. And then there are other criteria for non-school leaver prerequisites, which are on our website, so I won't spend too much time on it here, other than to say it is important. I would highly encourage you to go to the information session relevant to the discipline. So this was a broad session covering engineering generally, and I touched upon each of our 5 engineering degrees. However, there are dedicated sessions for civil engineering. There's one for electrical and electronics engineering, one for environmental engineering, one for mechatronics, and one for mechanical. And I highly recommend you go to those. I'd like to thank you very much, and I look forward to seeing you around campus. Thank you. Welcome to the virtual open day session for engineering at Deakin, where we're going to look at some question and answers around studying engineering at Deakin University. Welcome, I am Professor Ben Horan and I'm the head of school for the School of Engineering at Deakin, and I'm joined by my colleagues who are going to participate in the Q&A today. I'm going to ask them to introduce themselves and tell you a little bit about them to put them into context, and then we'll get to the questions and answers. I'm going to start with Ellen Moon.
Hi everybody, thanks for joining us. My name is Ellen Moon. I'm a senior lecturer in environmental engineering and I'm here to talk to you about that degree program.
Thank you, Ellen. Next, I'll go to Ashim.
Hello everyone, my name is Ashim Devnath. I'm the head of discipline of civil and environmental engineering. I'm here with Ellen to talk about civil as well as environment.
Thank you, Ashim. Pubadu.
Hello everyone, I'm Professor Pubadu Pathirana. I'm the head of discipline for mechatronics, electrical and electronic engineering, and I'll be talking to you about those big programs.
Thank you, Pubadu. And last but certainly not least, Tim.
Yeah, hi, I'm Associate Professor Tim Hilditch and Deputy Head of School and Head of Discipline for Mechanical Engineering.
Okay, thank you, Tim. Let's not waste time and let's get into our question and answers. The first question is from Mel, and it's, are there many women engineers? I like maths and problem solving, and I think engineering might be a good uni course for me. I think I might ask Alan to answer this in the first instance, and the other members could join afterwards if they'd like.
Sure. I think if you love problem solving, then engineering is definitely a great option for you. There are definitely less women engineers than there are men at the moment, but I tell you what, that's really changing and it's changing fast. So many engineering companies around the world are really starting to value diversity in their employees, not just in terms of gender, but all kinds of diversity of lived experience, different cultural backgrounds, different ages. And that's because we are ultimately about problem solving. And so by bringing in that variety and difference of lived experience, you can really help to bring a completely different angle to help solve some of the really big challenges that we're facing at the moment that engineers will have a big role in, such as climate change and food security and major issues like that. I'd also like to add that there are some really fantastic job prospects out there at the moment for female engineers. As I mentioned, an awful lot of engineering firms are really valuing that diversity, and we're seeing a lot of targeted kind of female-only recruitment. And a great example of that at the moment is in the infrastructure boom here in Victoria, where a number of the major construction projects that are happening actually have very clear mandates about the number of women that they need to employ. And so there really are fantastic opportunities, not only in that kind of construction and infrastructure space, but across all areas of engineering for women out there at the moment.
Okay, thank you, Alan. Okay, the next question I'm going to go to, I think, is applicable for everyone in this room. And it's going to be, what are the job prospects available for engineers? So we have a question about mechanical engineering, we have a question around environmental engineering. I think that's going to broaden that out to all of the 5 engineering disciplines we have. So what I might do is, seeing as you answered the last question, Alan, I might ask Ashim to talk to civil and environmental engineering, Pubadu to mechatronics and electrical engineering, and Tim to talk to mechanical. And so over to you first, Ashim, to talk about job prospects in civil and environmental engineering.
Thanks, Ben, and thanks, Ellen. That was really good points about the diversity in engineering disciplines. If you look at the Engineers Australia's employment vacancy report, that will give you a lot of details about different disciplines and which disciplines are in demand. You will be amazed to see that all disciplines, all engineering disciplines are in demand, particularly for civil engineering. In the second half of 2021, civil engineers are most in demand. This is primarily because Australia is going through an infrastructure boom. Federal government is spending $100 billion over the next 10 years on civil infrastructures. In Victoria, where we are, there is $70 billion of infrastructure spending happening over 150 projects, and 15,000 jobs are being created here. So what's happening across Australia and Victoria? These infrastructure projects require a lot of civil engineers. But are the only civil engineers working there? Of course not. There are managers and other disciplines, particularly environmental engineers play a big role there. As we go into a new project, we need to plan it. We need to look at the environmental sustainability aspects of those. There are mechanical, mechatronics, electrical engineering aspects also come in. But of course, the majority of these infrastructure jobs, because of the nature, will go to civil engineers. So for all disciplines, there is a big opportunity locally in Victoria, as well as across Australia.
Thank you, Ashim. Before going to Pubudu, Alan, is there anything you want to add from an environmental perspective?
I mean, I think Ashim summarised it really well. There's definitely loads of opportunities in that infrastructure space. But what I might encourage the audience to do is to listen to Pubudu's answer and also Tim's answer and think about the environmental aspects of the type of jobs and projects that they're going to talk about, because environmental engineers really do work in tandem with all other types of engineers to reduce the environmental impacts of their projects. So there are plenty of opportunities out there in all different spaces.
Thanks, Alan. Very good point. Okay, over to you next, Pubudu.
Yeah, so in terms of mechatronics engineering, it's a very interesting one because it caters to a wide range of industries. Anything that to do with the designing electrical, electronic systems and mechanical systems together. That is basically where our graduates are trained in to work in this space. So particularly, in defense, there are a lot of defense industries coming up and projects coming up as we speak, and designing machinery and mining equipment for particularly mining as well as agricultural industries. And new technologies in biomedical engineering space is very much in the mechatronic space. So this is actually a combination of conventional electrical, electronic, mechanical, as well as modern computing together to cater for the current industry needs. In terms of electrical and electronic engineering, our courses are basically to address the growing demand in the renewable energy power systems generation and distribution space. So that's where our focus as well as the current industry needs are. So that's to say that not only power, but it like Ashim said, and we have other disciplines coming together to create a complete engineering system. So that is how we contribute to the current industry demands.
Thank you, Pubudu. Fantastic answer. Okay, over to you next, Tim, for mechanical engineering.
Yeah, thanks. I think a little bit similar to what Pubudu said. Mechanical engineering is very invested in every sector across society, and I guess always will be. And they work very closely with the different engineering disciplines in a whole range of these sectors. Certainly, job prospects at the moment are good and will continue to be good. So we have a lot of graduates, a lot of students who end up working with a lot of the smaller, more innovative type companies that are coming up with solutions to productivity or quality of life or climate change sort of type issues around designing, developing those kind of solutions or products, manufacturing those products. Certainly some of the bigger, more established companies in Australia that whether it's around kind of locally built products for Australia or going into global markets in different areas, they certainly have a high demand around mechanical engineers about how to be competitive in those spaces, whether it's, again, in that design development, so it's a better product than what other people have, or simply around sort of manufacturing, maintenance, ensuring that the costs are as low as possible and they can continue to be competitive wherever they go. And then as you go to the really large sectors, and certainly, when you're talking about the mining industry, you're talking about, the oil and gas industry, and I guess there's a lot of challenges for those industries moving into the future around how they meet the demands that society and governments are putting on them. And a lot of those solutions around improving that productivity, around kind of cleaning up what they're doing, requires a lot of those innovative solutions, materials, machines that mechanical engineers will design, working with mechatronics engineers, working with the civil environmental engineers as that kind of goes into that bigger infrastructure type space. So I always like mechanical engineering because the breadth of industries, the breadth of things that they do, it's forever future-proofed.
Thank you, Tim, and all for those answers. And I think I'll just add one thing at the end. When I'm asked this question, and I have been in many times over the years that I've been doing this, I suggest that students thinking about studying engineering, open up seek.com.au and type in jobs for a graduate, and then insert your engineering discipline: mechanical, mechatronics, electrical, environmental, or civil, and just have a look at the types of jobs out there. I think you'll get a sense of the demand as well as the types of companies that are employing at the moment. Okay, so the next question we have is also going to be one that I think would have involvement from multiple panelists here, and that is around the industry partner that Deakin Engineering has or works with, and do we work with them? And I think I can start out by saying yes, absolutely. We work with the industry in a number of different ways. We have an industry advisory board which help advise and make sure that we keep our degrees closely aligned with industry. We have industry partners contributing in some ways to some of the teaching we provide throughout the course. And then there are lots of other ways in which we interact with industry. And we are launching, as of 2023, a new version of our engineering degree, the Bachelor of Engineering Industry Honours. And this degree is a 5-year version of the Bachelor of Engineering degree programs, initially available across 4 of our 5 disciplines. So it's available in the first offering across mechanical, electrical, electronics, civil, and mechatronics. And the way that this degree varies is there is a year worth of work experience or an internship in industry after your 3rd year of study and before your last year of study. So the 4-year degree becomes 5 years. So not something everyone would like to do. However, it does provide that greater amount of time in industry for those. It's not up on a VTAC yet, but you will be able to submit an application through VTAC before the end of the year if you are so interested. Okay, so now to specifics, industry partners. I'm just going to open the floor, and if any of the colleagues here would like to talk about some of the specifics in relation to industry partners that work with your particular disciplines, that would be fantastic.
Maybe I can start with this, all right? Yeah. Thanks, Ben, for this and good point about the new program. But I also want to highlight that our existing programs allow all students to have that experience of working with the industry. We have got this internship unit, which is covering across all of our programs, that gives you the opportunity to work with industry for 12 weeks, and you get the real sense of how it is like working in the industry. Not only that, but also the way we design our programs are industry-based, and we are focused on not purely looking into textbooks, but also looking into problem solving. And though most of these problems are coming directly from the industry. So you get a lot of experience while you study to experience how it is like working in the industry. Going a bit specifics into the civil and enviro space, that's the only space that I can talk about. So we have got various industry partners. As Ben said, it's not only about teaching, but also for research, consulting, and of course, including our engineering advisory board. To name a few, and I can tell you that for civil and enviro, I can't name all. I'm naming a few, not in any order of preference. So there are some local organizations, including the city of Greater Geelong, that we work very closely with. We work very closely with different industries, particularly coming in the construction space. For example, McConnell Dowell, Arup, Downer, WSP, and I can name a lot more, of course. Burnwater is one of our big partner across several areas of engineering. We work with the different government bodies, for example, Victoria Department of Transport. We work with the different structural organizations, different industries which provide different kinds of material, let's say metal, wood, timber, this kind of construction materials. So I can name a lot, but the message that I want to give to you is that in our teaching, research, engagement, in all space, you will be able to get the opportunity to interact with industry.
Okay, so I'll start next. So in in mechatronics and electrical electronic engineering, we have a number of projects that is engaging with technology development companies. There's a RFID development company that is working with us in using RFIDs for basically automating some manufacturing processes. And we have the Defense Science Institute, where we have a number of defense projects that our researchers are working on. And also Data61, the national body for information communication and communication technologies, Australia. They have a number of projects with us in technology development in various aspects. And also some hospitals, some major hospitals in Melbourne, and also in Australia, in other states. We have medical device design companies and government institutes working very closely with us for developing new technologies for the biomedical engineering space. So these are just to name a few projects that we have. And also in electrical and electronic engineering, we have a number of power generation companies that have very significant projects in developing new technologies for power distribution and also for generation.
Yeah, all right. So finally, similar to the others, that sort of jumping in and sort of naming a bunch of companies is difficult because of just the sheer sort of size and breadth of it. But certainly from a sector perspective, we have staff and students who end up working with, or staff who work with, and some students who end up working with, you know, the mining sectors, oil and gas sectors, transport, so some of the big automotive OEMs, agricultural sort of machinery design type manufacturing type companies. I guess one of the things that I find sort of the most exciting around being at Waurn Ponds at Deakin is having several companies on campus. So really innovative, forward-thinking companies like Carbon Revolution, Formflow. You can look up Manu Futures, so MANU Futures. They're based on campus, and there's a whole bunch of really innovative companies there that are doing this proof of concept sort of type work. And so they're taking some really, really clever technology, really, really clever material developments, and turning that into products that they're sort of commercializing and taking to market. A lot of our students end up working maybe on a final year project or with an internship with those sort of type companies or whatever as well. And a lot of it gets dragged into the classroom as well. So we have units like our third year product design development CAE unit, where there's an industry partner, students are designing a solution, a product for that industry partner, and the industry partner is kind of involved in it. And that's the kind of thing I guess we like to do in a lot of our project-based units. Is there's, you know, maybe a structural construction type industry, you know, maybe there's a more innovative product type company, just so students get more of an experience in the type of deliverables and the type of considerations in those industry. Certainly when we're talking final year projects and internships, you know, students get a lot of control and choice over where they will end up, what they'll be focusing on their project. Great possibilities. A lot of students have industry partners, and that can kind of flow into the internship where students get to go and kind of have that experience in the industry or in the role that they really like.
That's fantastic. Thanks, everyone. Alan, is there anything we've missed? So we answered the question correctly?
That's very comprehensive. I might just add that with respect to those internships, it's one of the most popular parts of our degree program. And I think one of the things that really sets Deakin apart from some of the other universities. We're here to assist students in finding really great placements with some of these industry partners that we have, but students are also very welcome to go out and source their own placements in areas that really interest them. And we're really hopeful as well moving forwards that there might even be some international placement opportunities. It was something that we used to offer prior to the pandemic, and we know our students really loved. And as travel opens back up, it would be great to see that coming back into the normality again.
Thank you, Alan and all. I'm glad you mentioned the helping students find that 3-month placement. And, you know, I was talking before about our 5-year degree, the 4-year degree. The 5-year degree, of course, has a year-long internship, but our 4-year degrees have a mandatory 3-month internship. Now, when I say mandatory, it's mandatory because Engineers Australia, our peak body, require this. So we have a question from an anonymous requester here, but how do you become a licensed engineer in Australia? Well, you're in the right place, because the pathway to becoming a practicing engineer is to do an undergraduate engineering program like the ones we're talking about here. So there are, of course, 5 which we offer in the School of Engineering, plus the sandwich degree, which has 4 different majors. The 5 degrees we offer, we've covered already, but we'll go through it again: environmental engineering, civil engineering, mechatronics engineering, electrical and electronics as one course, and mechanical engineering. So if you study one of those courses, or the 5-year version, at the end, you'll then be able to apply for graduate jobs in industry. There are other levels of engineering, including chartered engineering, but generally the entry is to undertake an undergraduate engineering degree. So you're definitely here in the right place. Okay. The next question I'm going to go to is maybe one that Tim may be able to answer, but possibly from help with others. So if someone's interested in exploring aerospace engineering, is it a good idea to study mechanical engineering at Deakin? Because, of course, there are specific aerospace engineering degrees at other places. Do our graduates who study mechanical engineering end up in the aerospace industry or not? Over to you, Tim.
Yeah, look, so I guess the short answer is some of them certainly do, and we have some students working at companies like Boeing and whatever in that kind of a sector. Obviously, there are a few differences between mechanical and aerospace engineering, and so a lot of the commonalities around materials, around manufacturing, around sort of thermofluids, so that sort of aerodynamic sort of type discipline. Then you have a lot of the simulation tools, the computer modeling simulation type tools that they sort of use are fairly similar as well. And so, there's quite a degree of crossover, and certainly any industries in aerospace that utilize those skills, mechanical engineer could absolutely get employed in there. So there probably are a few areas where there's maybe some of the skills or some of the things that we talk about and teach are a little bit different. Certainly, if someone is interested in that sort of sector, there's a lot of opportunities to tailor what you do. So, there's opportunities for electives. Final year project is half of the 4th year of an engineering degree, and certainly we have students that can and do their final year project in conjunction with a more aerospace oriented company, and then the internship as well. So there is that reasonable degree of flexibility for almost a quarter of the degree. There's some choice around really choosing and orienting what you do towards that industry.
Thank you, Tim. Fantastic answer. Pubudu, did you want to add to it?
Yeah, I just want to add that we are very happy to say that the last year we had 2 final year students who actually undertook a course in mechatronics course, and they did a final year project in embedded systems design and controls, and they ended up getting a job immediately after their graduation in BAE Systems, British Aerospace Systems here in Melbourne. So so they are very happy. I had the privilege of writing the recommendation letters for them, but there's a wide variety of skills that these companies need, not just necessarily 1 or 2. So I think that our courses are somewhat generic in addressing the real industry needs out there, and not really focusing in on one particular aspect.
Thanks, Pubudu. Very good point. It's hard to go anywhere to find a system that doesn't have electronics in there to help control it, including aerospace systems, and BAE is a fantastic example. Now, not necessarily a question, but just a reminder from me to people that this is the virtual open day Q&A session, and there have been presentations prior to this, but if you are interested, please do come down to our campus. For the engineering campus, this is our Warn Ponds campus. On Sunday, the 7th of August, we will have physical open day activities. So you can come and walk through our building, and many of the things Tim talked about before, including Manu Futures. And while we not necessarily take a tour of Manu Futures, you'll be on campus and we can talk and show you the activity that's happening around the place. So something I highly recommend doing to complement what we're doing here today. Okay. The next question I'm going to go to is, I think one Alan partially answered before, but I think it's worth circling back to. So Alan, are environmental engineers in demand?
Thanks, Ben. Yes, they absolutely are. And across every sector and pretty much every type of project that my colleagues have talked about today. As Ashim mentioned, because of the infrastructure boom in Victoria, but also elsewhere in Australia, every single one of those projects employs many, many environmental engineers from the planning stages through to the implementation and the ongoing monitoring that has to be continued afterwards. You know, think about soil contamination, water contamination, monitoring for air and noise pollution, dust, that type of thing, putting into place the plans around protecting the environment during and after the project. We're also seeing huge interest from the resources sector for environmental engineers at the moment as they seek to reduce their environmental impact. You know, I think Australia is incredibly well placed for the electrification boom that's coming. You know, we've got an awful lot of deposits of battery metals like copper and zinc and nickel, and all of that is going to require, all of these new exploration projects that are happening are going to require environmental engineers. And of course, we've got the really kind of traditional, I suppose, places that environmental engineers have typically been employed. All levels of government, from kind of local council through to state up to federal government. You know, one of the biggest employers probably of environmental engineers from Deakin is actually Barwon Water and other different water utilities in that space, for that crossover with civil engineering. Both degrees do study that kind of water engineering space, and many of our graduates do find work in the water utilities.
Thank you, Alan. Now, we have a question here, which is one we commonly get asked, and it's around, if I wanted to study mechanical engineering or civil engineering, could I change my mind partway through the course? The answer is yes and no. Depending on the course you're in and depending on the course you'd like to change to, you may be able to change possibly up to the end of the first year, possibly a little bit later. It does get more difficult the further along you go. However, in the first 6 months, it's very, very easy to change across courses. But look, what I recommend you do is get in touch and talk to a person about our courses, because then they can look at the specifics of your situation and what that would mean, because you do want to take it into account. If you do go further on in your degree, then without being able to change, without having to redo things, you will need to redo some units. So it's something you want to give a fair bit of consideration to. So what can I
just quickly add to that, Ben? Just highlight though that civil and mechanical do have a common first year, and electrical and mechatronics have a common first year. And in general, when looking at previous units or previous courses or things that students have studied, then we always, I guess, try and figure out how we can be as sort of generous and accommodating as possible to allow students a little bit of flexibility in doing these sort of things. You know, if you have done any previous study before, maybe at a TAFE or maybe at another institution, then there is a recognition for prior learning type process that you can absolutely investigate and look at whether you can kind of apply for that. And that also does help a little bit when we're kind of moving around within our programs.
Definitely. Thank you, Tim. Look, we're almost out of time. So what I'm going to do is, first of all, thank our presenters for being here today and sharing their wisdom with the group. But more importantly, thank those of you who are attending online for your interest in these courses. I might, wrap up by saying engineering is a fantastic career, irrespective of the discipline you choose to go into. It's a career that will challenge you, provide amazing career opportunities, and take you places that sometimes are really hard to imagine. Please do check out the Physical Open Day if you can. We'll all be there, as well as the rest of our staff, and we'd love to meet you in person. And with that, enjoy the rest of your Sunday.